Welcome everybody. Today we're talking about 4.2, solving systems of equations by graphing. So last class we looked at different types of lines. So one type, if it has one solution, the lines are intersecting or crossing each other. And intersecting lines, if you're just looking at the equations, they're going to have different slopes. And then their y-intercepts could be the same or they could be different. But what matters is they have different slopes. No solution are lines that never touch, and lines that never touch are parallel. And parallel lines have the same slope, but different y-intercepts. And then infinite solutions, those are touching everywhere, so they are the same line. And same lines are going to have the same slope and the same, struggles. I'm just going to erase that. Take two. Same slope. Talking and writing is hard. And the same y-intercepts. So everything is going to be the same. And those are going to have infinite solutions. So today we're going to be graphing. So here's some steps. So writing equations in slope-intercept form if needed. So if your equation isn't in y equals mx plus b, we're going to rearrange it like we learned last class. And then we're going to compare the slopes of the equation to determine if they're the same line or if they're intersecting, so like what type it's going to be. We also see that when you graph it. Then you're going to graph both equations and find the point where the two lines intersect, which also means like where they cross, if they cross at all. And then you're going to write your solution as an ordered pair. And what an ordered pair means is writing it as like x, comma, y. So let's look at an example. So what I'd recommend is having two colors. So I'm going to star the first one with my first color. So my first equation will be in blue. So it's in y equals mx plus b, so that's good. And if you look at the two slopes, they're different. So right away, I know these are going to be intersecting lines. And intersecting means they should have one solution. So now to figure out what the solution is, we're going to graph. So starting at -3, it's my y-intercept. And then my slope is -5 over 4. So we're going to go down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then 4 to the right. When you graph systems, you want to graph as many points as possible. So I'm also going to go up and to the left. 1, 2, 3. Oh. So that's as many points as I can fit on the graph for that line. So now I'm going to draw my line through them. Then I would pick a different color for the second line. So this one, our y-intercept is at 5. So I'm going to start at 5. And then my slope is +3 over 4. So I'm going to go up 3 to the right 4. Or I could go down 3 to the left 4. Ooh, boom. So as soon as they touch each other, you are good. You don't have to draw any more points. Because that point where they crossed, that is their solution. So that is at the point 1, 2, 3, 4. So we went -4 and then +2 to get to that point. So right here, -4, up here, +2. So that's the point that is the solution. So if I were to plug -4, 2 into both of those equations, it would work for both of them. So let's look at another one. So here's my one in blue. Oh, I guess right away you can see they have different slopes. So I know my type will be intersecting, which means they should have one solution. And I like my slope to be a fraction, so I'm going to put the invisible 1 over 1 for the first line. So I'm starting at 4, and then I'm going to go down 1 over 1. That feels like a lot of points. Maybe I'll do a few in this direction. So hopefully that'll be enough. I'm going to draw my line through it. And my second line, again, I want my slope to be a fraction, so I can always put a 1 underneath it. So I'm going to start at 5. And then I'm going to go down 2 to the right 1. Boom, they hit. I like to have at least 3 points, so I'm going to draw one more. So as I draw my line through, the 2 points overlapped right here. So that is the point 1, 3. So 1, 3 is a solution that would work for both equations. All right, so we get another one. Ooh, this one looks special. So we've got x equals -4. So a reminder for x equals, you're going to go on the x-axis to -4. And then these points, everywhere where x is -4 is straight up and down. And then y equals 4, I'd go up to y is 4, and there's no x, so there's no slope. So I would just do a flat line there. So my solution is where they cross each other. So these lines intersected. So they have one solution, and that solution is at the point -4, 4. Which you might have noticed from the original equation, it tells you x is -4, y is 4. And this is my x, this is my y. So right away, without even graphing, we knew what that solution is. All right, next one. Ooh, these two have the same slope, so -2/3, -2/3. And they have different y-intercepts, so I know these are going to be parallel. So they're going to have no solutions, or none, number of solutions, and solution, no solution. But it's a good idea to still graph them. So our first line is at 3, so we can prove that that actually works, because right now you're just taking my word for it. Down 2 over 3, down 2 over 3. All right, so there's our first line. And then our second line starts at -1 and then goes down 2 over 3. So hopefully now you can see this is the reason why, if they have the same slope, they have no solutions, because these lines are never going to touch because they're parallel. So parallel lines go on forever, never touching. All right, just two more. Ooh, okay, so here's where the steps come in. So this first equation is not in the y equals mx plus b, and we want it to be. So we're going to rearrange it. So down here, I'm going to show my work. So I like for there to be a number in front of every letter, so I'm putting a 1 there. So to move the 1x to the other side, it's a positive 1x. So to move the whole thing, I'm going to do the opposite of a positive, and I'm going to subtract the 1x. So I'm left with -2y. In y equals mx plus b, the x goes first. So I'm going to put -1x first, and then it's a positive 6, so +6. Then I'm going to divide by -2. And when I do that, I divide everywhere by -2. So y equals negative over a negative is a positive. So it'll be +1/2 x minus 3. So then we can graph that. So I'm going to go to -3 on the graph, and then up 1 over 2, up 1 over 2. Or down 1 over 2 to the left. Then my other equation, I'll have 3x plus 4y equals 8. So again, positive 3x, if I wanted to move it, I would subtract it. And we like the x to go first in this equation, so I'm going to write -3x, and then it's a positive 8, so +8. And then to get rid of the 4, dividing by 4 everywhere. So y equals -3 over 4x plus 2. So we'll start at 2, go down 3 to the right 4. Boom, they hit. Awesome. That means we did it right. So they won't always hit on a nice point, but in this class they will, because we're going to give you nice ones. So right here they crossed, so our type is intersecting. So there's one solution, and that solution is at 1, 2, 3, 4, -1. Okay, last problem. So the first equation is not in y equals, so we need to move it around. So we're going to solve it down below. So positive 5x, to move it we would subtract. So -3y equals -5x minus 3. This time it was a -3, so that's why it's minus. Then we're going to divide by this -3 everywhere. So y equals negative over negative is a positive. Negative over negative turns into a positive. So the graph, we'd go to +1, and then up 5, 1, 2, 3, 4, 5, over 3, or down 5, 1, 2, oops, 2, 3, 4, 5. Hopefully that's enough points. Then our second line is y equals -4. So I know I start at -4 and there's no x, so there's a 0 slope, so it's going to be flat. So where they crossed was right there. So that is the point 1, 2, 3. So -3, -4. So our type is intersecting. We have one solution, and that solution is at -3, -4. All right, you now know how to solve systems by graphing. So try out the practice, and I hope it goes well.